Hello. I'm going to wait 1 more minute and then we will start. Yes, go ahead. Yes, I am going into my junior year. Thank you. What year are you going into, or what grade? Cool. Nice to meet you too. All right. I think we can start, and I may pause as we go to admit more people if others join. But this is API design. Wait, hold on 1 second before I start. Okay. All right. And more people are still joining. Another person. Okay. Now we will start. My name is David Fahim, and this workshop is about designing APIs. More specifically, streamlining the process of building REST APIs with the OpenAPI standard on Swagger.io. Now, I understand that that's a lot of words, and I will break down what all of this means soon. This workshop assumes that you are already familiar with the core concepts of web development, such as the distinction between clients and servers. And this workshop also assumes that you're somewhat familiar with writing JSON. We'll actually be using YAML, but if you're unfamiliar with YAML, that's perfectly fine since it's actually very similar to JSON and it's pretty easy to pick up. So yeah, let's get started. So this is the agenda for today's workshop. We are going to learn about APIs and their purpose. We will explore REST APIs and their standards. We will learn about OpenAPI features and the use of Swagger.io. We will build a simple OpenAPI design on Swagger.io. And finally, I will reiterate some of the workshop's key points. So starting with the most key component of this workshop, what are APIs and their purpose? An API, or an application programming interface, is a set of protocols, routines, and tools for building software and applications. It specifies how software components should interact and allows different software systems to communicate with each other. It can be used to access web-based services, databases, and other resources. It plays a crucial role in enabling software solutions to connect and interact in today's interconnected digital world. Besides these two items, we need to understand two other important words that you may not already be familiar with: resources and fields. What is a resource? Well, a resource is an object or a collection of data. For example, a resource could be anything from a user account to an image. Any resource, such as a user account, may contain several resources within them, such as a profile photo or a collection of contacts. In that case, these would be called sub-resources. For today, just think of a resource as a set or individual pieces of data. And a field, you also may use the word property for this. Field is a component of a resource, but it's not necessarily a sub-resource. A user account, for example, may have a username and a profile photo. The username is a field. The profile photo URL is a field, not the profile photo itself, but the profile photo URL is a field. But the profile image file itself is a sub-resource. Fields are usually represented as key value pairs in JSON when transmitting and receiving data. Now let's explore an important and very common standard for APIs. A REST API, or Representational State Transfer API, is a type of API that adheres to the principles of the REST architectural style. It allows for an interaction with web resources using the HTTP protocol. REST APIs are stateless, meaning that each client request to the server must contain all of the information necessary. Hold on, one person just joined. Must contain all of the information necessary to understand and process the request. And they use standard HTTP methods like GET, POST, PUT, DELETE, and so on. REST APIs follow different standards such as these so that building and maintaining interconnected applications is easier. And as you can imagine, if everyone is following the same standard, it's easier to maintain all of these applications. Now let's explore some of these standards in more depth. HTTP methods. REST APIs use standard HTTP methods. To create a resource or simply send data, you use a POST request. So from the client to the server, if the client is sending data to the server, it's going to use a POST request. And to get a resource or to retrieve other data, you use a GET request. To update a resource, you use a PUT or a patch request. And finally, to delete a resource, you use a delete request. You may notice that PUT and patch requests seem needlessly redundant in that they do the same thing. So what's the difference between PUT and patch requests? Another person, hold on. Okay. Both PUT and patch update data. However, a PUT request will create the resource that is trying to update it. However, a PUT request will create the resource that it is trying to update if that resource doesn't already exist. Because a PUT request may need to create a resource, in that case, it should always contain all of the necessary resource data to do so. So that means all of the fields in order to create that resource. So that would mean including the fields that need to be updated, as well as the fields that may be unchanged. A patch request, on the other hand, only includes the fields being updated. Therefore, a patch request cannot create a resource and will return an error if the resource does not exist. In the context of REST APIs, statelessness means that each request from a client to a server must contain all of the information necessary to understand and process that request. The server should not store any information about the client state between requests. This makes the server more efficient because it doesn't need to manage or remember any client state. It also makes APIs more reliable, as the server doesn't need to handle a situation where a stored state might be lost or corrupted. And I actually want to go back to this point right here. So if an object already exists and you send a post request, most often you should send back an error saying that that object already exists. You can't send this post request because a post request is only for creating objects. A post request is only for creating objects. A put request is for overriding objects or updating them, really. And a patch request is for just updating those objects. Okay, and yes, and you can see this diagram here. As I just talked about statelessness, the client API request can go to any of these servers. So if you have one server, there's something called vertical and horizontal scaling. So you can only vertical scale so much. That means adding more processing power to one machine, adding more storage and speed to a single machine. And you can only do that so much. So you can't run your entire app on one machine. Any large app is going to use many, many, many different servers. And therefore, you need to use horizontal scaling, which means creating more machines instead of just adding processing power to one machine. So you can add processing power to one machine, but there's a limit to how much processing power you add. And eventually, you just need more servers. You need more of those machines. So statelessness makes it very easy to horizontally scale in that any client API request can go to any of these servers because every request contains all of the information necessary to understand and process the request on the server. Therefore, the server doesn't store any information about the client when they request it. They don't store it in a variable or anything like that. There are no side effects from functions that are called on the server. So it's not going to store any data about the client. It'll instead just take the input and output something. And maybe it stores data in a database that all of the servers share access to, but it's not going to store information on the server directly. And yeah, the next one. Client-server architecture refers to the separation of concerns in the system. The client is responsible for handling user interface and user experience, while the server manages the processing of client requests and handling of resources. The client sends requests to the server, which processes these requests and sends the appropriate response. This separation allows the client and the server to be developed independently, as long as the interface between them is well-defined, such as with OpenAPI. We're going to learn how to use OpenAPI to make that easier, to make it easy to write these independently so that other people can use your API and it's just easier to develop your API. Cacheability in REST API means that the server's responses can be cached or temporarily stored by the client. This reduces the load on the server as subsequent client requests can be fulfilled from the cache instead of having to go to the server every time. It also improves performance by reducing the network load. The server must provide information in its responses to let the client know whether the responses can be cached and for how long. So usually it'll send back information about any image or resource that the client fetches from the server. It'll send back information that contains some sort of date when the data expires. So you can see this workflow. If it's not in the cache or the caching duration has expired, it fetches it from the server. And this sends the resource with the caching duration. And if the caching duration is not expired and it can find it in the cache, it just takes it from the cache and it doesn't make that extra request to the server. All right, this is the second to last one. A uniform interface simplifies and decouples the architecture, enabling each part to evolve independently. The four guiding principles of a uniform interface in REST are, sorry, more people joined. The four guiding principles of a uniform interface in REST are identification of resources. Individual resources are identified in requests, for example, using URIs or uniform resource identifiers in web-based REST APIs. Manipulation of resources through representations. When a client has a representation of a resource, including metadata, it has enough information to modify or delete the resource on the server. The server has self-descriptive messages. Each message includes enough information to describe how to process the message. And some APIs will even provide this. This part's more optional, but you should provide this if you can. After accessing an API, clients can navigate the rest of the application purely by following hyperlinks that are sent back. The layered system architecture allows an application to be structured as a hierarchy of layers, each providing a specific set of responsibilities. This enhances the modularity of the application and allows parts of the system to be evolved, updated, or modified independently. In the context of REST APIs, it means that the client doesn't need to know whether it's directly connected to the end server or an intermediary along the way. It promotes separation of concerns as each layer focuses on its role without worrying about what the other layers are doing. OpenAPI is a standard. OpenAPI is a standard format for describing APIs. This description, written in YAML or JSON, can be used to design APIs. Tools such as Swagger.io can automatically test your API, generate API server code, generate API client code, and even generate documentation. Normally, one would have to write the API server code, design a client, design tests for their API, and write documentation. The most challenging part of this process is that when making changes or adjustments to an API, one must update all four of these code bases, which may introduce inconsistency and consequently bugs. OpenAPI centralizes all of this into one concise but highly descriptive markup language. When integrating OpenAPI with Swagger.io, one can generate server code that will automatically verify incoming requests to ensure that the request data matches the API definition. Now we are going to create a simple API with Swagger.io. So I suppose the first thing that you should do is visit Swagger.io. And I'm going to share my screen. All right, so the first thing that we will do is, I should actually probably start from the beginning, so hold on. Okay. Visit Swagger.io in your browser, and you should see this page, and I'll send the link in the chat. And the first thing that you will do is create an account. So go to sign in. And for me, it'll automatically sign in. But for you, you should create an account. I believe there's a GitHub sign-in option, so you can just sign in with your GitHub account too. And I don't want to go ahead while people are still signing up, so I will wait until 3:21. All right, once you have your account, you should be on the home page. I'll send out this link too. You should be on the hub, and this will have all of your APIs that you've created. So first thing that you can do is you can create a new API by going to the top left. So create new, and you'll select create new API. Now from here, make sure that owner is this. If you create an organization or different app, then it'll do that. And they give you a free trial for that. So I've actually tried that myself. And you can do OpenAPI 3.0. And select a template. Select the IoT. No, actually not IoT. Select the inventory API, which I believe is just the simple API. Select the simple API right there, and that'll be what we're working on. So select simple API, and then name your API. You can name it demo or something. And then we will, and then you will leave auto mock on, and turn your visibility. You actually can't make it private, but I'll explain. So Swagger.io, if it wasn't clear in the presentation, Swagger.io, you don't need to create these APIs. OpenAPI, you can download, and in plenty of IDEs, you can just edit your OpenAPI. You can edit your OpenAPI definition inside of just IDEs on your computer. So you don't even have to have Swagger.io, but it does host your documentation, and it provides an interface for testing your API and so on. So we'll use this for today. So you click Create API. And then you'll see this simple inventory API. So before we actually get into the code, I want to show you around the interface. So up here, you can actually view the documentation that gets automatically generated. So right here, you click View Documentation. This adds documentation automatically. So you don't have to actually write your documentation like I said earlier. It's kind of being created as you write this definition inside of here. Now, so you can open this documentation yourself, though I don't believe it's showing up on my screen for you. Another thing that you can do is you can go to API options, so you can connect it with a GitHub repository as well, which is very useful. And you can also share your API since it is public. And we'll actually look under the. I think the export tab is kind of one of the coolest parts about this. It's definitely one of the coolest features about this whole thing. So we'll look at the export tab at the end. But right now, let's look at all this. So we start by defining our OpenAPI by our OpenAPI version. And And this is the current version of OpenAPI. The next thing that we do is we define our servers. So like I mentioned earlier, Swagger.io can test your API for you. So for that reason, you may want to have a server that will, you may want to add your own server URL that you can send these requests to for testing. Just like so yeah, right here, you can do try it out. And in here, you can actually test it. So under one of these definitions, you can expand the definition. So this would be a post request to /inventory. Most likely, because it's a post request, like we said earlier, it's creating a new item because it's a post request. And then we click try it out. And you can execute this and get back a response. So we know that that path works as we expected. So the next thing that we do is we define information about it. We have a description, and we identify the current version of our API definition. So when you create a new version of this definition, you probably want to update that version in here. You will also, you can also change the title of your API here. And notice that the title is different from the name that you use to identify it inside of your accounts. The name that you use to identify inside your account is different from the title that people will see like on the documentation page. So that might be why you want where you want to change the title. And you can also contact information, which will add this option to contact the developer. And you can include a license, so people understand how they can use this software. And you can include like an open source license there. There are different tags here. And these are used to basically just logically group all these different operations. So this is especially for people reading your documentation. And now the most important part, arguably, is the paths. This is where you're writing, actually, the components are also very important. We'll look at the components later. But the paths, this is definitely one of the most important parts. And I'd kind of like to go over the components first. So, because I think that's the most logical order. So let's scroll down components and go over this section. So this includes reusable components for the API. So if you remember what I mentioned earlier, APIs can check any request data and make sure that it is defined properly. So any request to the server, the API can make sure that it matches what it expects, and then it'll filter out any requests that are not what it expects. So this kind of defines different parameters, or I guess you could say properties or fields for any different modifications to resources. And another thing that it's important for is people, when they read your documentation, they can know what to expect. So when they read your documentation, they can see, oh, I'm expecting back an inventory item. That means that it's going to have a name. Otherwise, you have to explain that yourself. You have to manually write that out. But right here, it just defines that for you. And now you can reuse this component. The whole point of components is that you don't write this out every single time you like send back an inventory item and you expect an inventory item. You don't write all this code over again. So it's reusable in that way. If you want to update something about it or change something, for example, if I want the ID to instead be a number, and I want a different example, so then I would change it to a number. And then you can also include like maximum and minimum. So And it also has autocomplete, which is helpful. So maximum. And you can say 100. So say I wanted a 4-digit ID. I would have 1,000 as my minimum. Sorry, that's my maximum. 9,999 is my maximum, and my minimum would be 1,000. So that would mean any ID that I send back to the client for inventory item would be 4 digits, and any ID that they send me, that the client sends me, the server, I can expect it to be also 4 digits. And if it isn't 4 digits, then they're going to get an error back, and they will know why, because it says this in the documentation. And actually, I kind of went out of order here. So let me go start right here. So these are the different a schemas just identifying is just describing what something looks like or what something is. This is the name of one of our components, inventory item. It's an object, basically JSON. So that's what type object means. This is saying that these fields are required. So when we send this object back to the client, they know for a fact that they are going to receive an ID, a name, a manufacturer, and a release date. If you say that these are required and you don't send all 4 of these back, then people using your API, their applications are going to break. So you need to make sure that you follow these rules on the server. So they expect these back. And if you're expecting a client to send you an inventory item, you can also expect these. So you can know that they are going to send these as well. And if they don't, your server will reject that request, send them back an error. Now, these are the properties, and they will know what to expect. So they know that the release date is going to be formatted like this. They know that the manufacturer, and actually this is very important, the manufacturer, notice that $ref. That is actually, so that's a reference to another component. I'm actually going to hit enter right here so we can see a little bit better. So this is a reference to another component, which is the manufacturer object. So now you know that under manufacturer, you are going to find a manufacturer. Well, where's manufacturer? It's under /components. So components, it's kind of like a path to this. So components, under schemas, and under manufacturer. And this will actually kind of automatically insert this definition in there for you. So if you look at your documentation, you can see under schemas, this has all the definitions so people can read your definitions. Inventory item, you look inside of there and you see all of these different definitions and it explains them. And then under manufacturer, it's a reference to this, but you don't actually see that. Instead, you can click this expanding icon and it'll automatically include all these things from here. So now you can see all these things from manufacturer inside of here. Now, under manufacturer, you can find name, homepage, and phone. You can find all these same things. So it kind of just is replicating that, I suppose. So, and this is also how you will reuse components. So up here, when I say that I'm expecting a inventory item, I can use that reference right here. I can use this reference. So this has the same properties. This one, it only requires name. So no client should expect to receive a home page and a phone back. They need to check to see if they received a phone or a home page when they get that response. They know that they will receive a name, but they don't know about everything else. So they need to actually check that. And you, as the server, don't know that the client will actually send these things to the server. So you shouldn't expect or assume that the client is going to send all these different properties. You should check as the server. So now let's go under paths. So this connects back to the HTTP method slide. So we have the /inventory path, and we have a GET request. So this is one of the types of HTTP requests, and this is a GET request. So user identifies an object using probably the inventory item's ID. So they define the ID, and then you send back the actual inventory item. Now, you can't infer all that just by looking at /inventory. So that's where all this description comes in. So the first thing that we do is we define the summary. So we say it's going to search our inventory. So this is kind of just a description for what it does. And we also identify the operation. And this is a more detailed description. So searches inventory, the summary is just displayed right next to it. So it shouldn't be super long. It displays it right next to it into the documentation. If you expand it, then you see the actual long description. So these are the different parameters. So and you define if certain things are required. So this is why on you'll see later, but Swagger.io will automatically check these things for you. So you don't have to worry about checking this for the client. You can know safely that the client is going to send these different parameters, assuming Swagger.io correctly generated your server code. And this is in the query parameters. That means query parameters are more like after the URL, you have a question mark, and then you have a bunch of different variables. So you might have, I'll write an example right here. You might have example dot, I should write out the full URL, HTTPS, example or api.example.com. And then you have the question mark right there. Or maybe in this case, we would have inventory, question mark. So these are different query parameters. So this name is called search string. Okay, so that means that it's going to be called search string. Search string equals, and pass an optional search string for looking up an inventory. So I will say, so this probably finds it by the name. So I would say something like, so of course we would have to implement this on the server, but I can assume that this is probably going to return a name. And that's kind of what this description says. By passing the appropriate options, you can search for available inventory in the system. So search string, I will search for a bottle of water. So my search string is bottle. And I can also add more search parameters. So I can put an ampersand and put another parameter. So I can say skip. Now, what's skip? So I would, by looking at this skip, I would think that skip is just a Boolean value, maybe true or false. I mean, that's what most people would think. But no, it specifies what it is. It says the number of records to skip for pagination. So this is specified as an integer, and it's a 32-bit integer. So at most, it can be 4 billion or something around there. And the minimum value is 0. So it has to be a non-negative integer. So it can be 0 or greater. So it has to be non-negative, and it can be anything else. So I'll just say 0. And skip equals 0. And then the last one, I could say limit. Limit equals 25. And you'll notice that that none of these are really required. So if you look under here, these ones don't seem like they're required either. Yeah. So these aren't required, and you can specify that. I would probably recommend always specifying it. So in these, it should include that. It should specify that required is false. So you could just make a request to here with nothing, And probably the expected behavior is that it sends back all of the inventory items because you didn't specify any search. And this specifies the different responses that the client can expect back. So what should my client that I'm building expect? Well, it should expect search results matching the criteria. Okay, well, what does that look like? I don't know what that looks like. Oh, it's an array. It's a list. It's a list of what? It's a list of these items, search inventory, or sorry, inventory items. Okay, so then I can go down here and I can see I can expect inventory items. So it actually says the response code 200, it's going to send back one of these. And it shows a little example value, because we specified these example values here. And even if we don't specify example values, sometimes it'll automatically generate those for us. But you should always add example values. So now it includes this example value of what a person can expect back. And you can go to inventory item and you can see what you can expect in more detail. And finally, we have a description, which is the inventory item to add. Okay, so wait, hold on. That's a different path. Then response code 400. This is another response code that users can expect. So 200 always means success. 200 always means success. So whenever you visit a page on a website, it's going to return back 200 most often, hopefully. 404 means a resource is not found. You're probably very familiar with that. 400 means that it's a bad input parameter. 403 means that you're unauthorized. And 500, it means that there was an error on the server that couldn't be identified. So it's just a server error. So any code that starts with 4 means that it's a client error. It's an issue with the client. So you're blaming it on the client if it's error 400. So 400 through 499 is a client's problem. 500 through 599 is the server's problem. So that's something where an error happens on the server. And 200 means that there was success. Now a post request. So the summary for this is it adds an inventory item. So we can see the summary right here. Adds an inventory item. And the more detailed description adds an item to the system. So if you receive a response that says 201, you know that you successfully created the item. That's the description for that. 400, invalid input, object invalid. 409, the description is an existing object, an existing item already exists. So this is also why you might have different types of requests like put or pass. If this was a put request instead, if we put instead of post, then we should probably get rid of this. And notice it actually also color codes, which I actually really like. It color codes all these different requests. So you'll see that this 409, we probably should not send that back to the client because it's a put request. And put requests, if the item already exists, a put request is for updating an item. So you're not going to send that back for a put request. But for a post request, which is solely for creating an item, you should send that back to the client. Now the request body, this specifies what the server expects from the client. So clients can send data to the server in a variety of ways. They can send it inside of the URL, which looks like this. You specify the parameters, and then you have all of this. It can also specify data to send to the server in the body, in the request body, which is used in post requests. I don't believe you can send the request body in GET requests, but if you can, don't do it because it's bad practice, and I'm pretty sure not all browsers even support it. So some browsers just might not let you do it. So I would not recommend doing that. Definitely follow the standards. And this specifies, so it expects JSON, which is the common language used for servers to send back data. Another common language is XML, but you'll usually use JSON. So Java object notation, you send to the server, and the server will also send back JavaScript object notation with those properties or fields for that resource, identifying all those different things. Now, that is basically all for this. So there's actually one, this is the coolest feature with this. So make sure that you save this. And you can actually export. So go to the export button in the top right. This is such a cool feature. So you can look at code gen options. There's a lot of different options here. You could look at this so select which language you would want it generated in. Say I wanted it generated for Node.js or Golang. I really recommend Golang because it's actually very easy to build a. It's very easy to learn, and it compiles directly to machine code, which means that it runs very fast on the system. So compiles all the way down to assembly code. So it runs directly on your machine. There's not like some extra layer like with JavaScript. And Golang, there's not very many ways to do more to do a single thing. So you kind of do it one way, and if you're reading someone else's code, it all automatically makes sense. So it's great for open source projects. And I definitely recommend using Go. So different languages will have different things that you can specify here. So you could specify the package name or something, but these are features inside of Go. You don't have to worry about that. So after you go to those code gen options, you can generate documentation. So it doesn't have to be hosted on Swagger.io. You can download the HTML documentation that is generated. So you can just generate static HTML, or you can generate this dynamic HTML, which I believe means that you can, click on these items and open them up and such. So you can, so it's more interactive. You can download the API definition right here. So you would download it in YAML if you wanted it to look like this. JSON looks a bit different, but it's still the same concept. And resolved, basically, if you select resolved means that it automatically replaces these ref things with whatever's here. So I don't like downloading it resolved. I like downloading it unresolved because I don't want these things replaced with like the actual items, because that kind of defeats the whole purpose of having reusable components. I really like the references to components so that, you have all the components in one area, and you aren't updating it in multiple places. So I would download YAML unresolved, and then you can generate the server stub. So this is really cool. You can download a Go server, and this will generate all of the server code for you. So you still have to write the individual functions. It'll automatically create a file that has all of the different functions for you to fill in. So this file has all the different functions, and it has inputs to those functions, and all you have to do is worry about implementing those functions, implementing the output of those functions, and you don't have to write any of the actual server code that's like sending back errors or communicating with the client. You don't have to worry about that. And it just takes a huge part of development off of you. So it's really quite nice. And the client SDK, you can generate an example client right here. So you can generate code to make requests to the service. This would kind of serve as an example. And yeah, that is all. How much time? Okay, yeah, we still have 10 minutes. Does anyone have any questions? All right, well, you guys are free to go and stay afterwards if you have any questions. And good luck on the hackathon. Yeah, thank you for watching. Yeah, you're welcome. No problem. All right. If there are no questions, then I will be logging off. Thank you for watching, guys.